Good morning all. I'm going to start my video lecture series based on database management system. Now my topic is an RAID, right? This is an most important topic for an database management system and operating systems too, because it having an based upon a disk management, how the data will be stored and how the disk will be used for the storing the database in the server. Now my topic is on RAID. RAID means redundant array of independent disk is a way of storing the same data in a different places on multiple hard disk or solid state drives. RAID means it is a redundant array of independent disk. It's a way of storing the same data from different places, like duplicating the informations or the separate disk will be happening for a separate data. Multiple hard disks will be used and solid state drives also be used. It is used to protect the drive failures. If the any drive will be, if A contains two times, if one contain A will be failed, means the other A disk will be used for the retrieving the data. So the main advantages of a RAID is, if the drive gets failures, it's easy to assess the other drive of the duplicate values. It works on the RAID works plays data on multiple disks and allowing input and output operation to overlap the balanced way. Both input and output operations will be happening, but it cannot be overlapped. Gets and balanced way, and the input output will be used, operations will be used. RAID works in multiple ways, and multiple disk will be allowing input and output operation to get an data from the disk, and then it gets an improving a performance because multiple disk increases the mean time, because failure storing data redundancy also increase fault tolerance. This is the RAID array appears with an OS is a single logical drive. In OS, the RAID will be appear in a single logical drives. RAID employ techniques and disk mirroring, disk stripping. Mirror will copy identical data onto more than one drive. Stripping means partitions help spread data over multiple disk drives. Likewise, we are having an RAID levels. In this, we are having an level up to level 6, 0, 1, 2, 3, 4, 5, 6, and RAID levels mean they use different versions called levels. The original paper that coined the term and developed the RAID setups concepts, different 6 levels of RAID 0 through 5. Now RAID 0 is it is having a stripping but no redundant of data. It offers best performance and does not provide fault tolerance. In this, we are having a block diagram, like block 1, block 2, block 3, block 4. These are stripping levels. If one contain here, the another block disk block will be 2. It's not duplicating the values 1, 2, and then 3, and then 4, and then 5, and then 6, and then 7, and then 8. It not duplicate the 2 disk values. This is a stripping, 0 level of stripping. It also a disk mirroring. In RAID 0, it's on the stripping level. In RAID 1, it is called as disk mirroring. At least 2 drives have duplicate the storage one drive. Disk 1 contains 1 disk. Disk 2 contains 1 disk also. No stripping. It cannot be different from one another. The same level of disk will be stored in the one side of disk, and then same level of RAID stored in the another disk. See, here we are having a block diagram. If block 1 appeared here, and then block 2 appeared here, block 2, block 2, block 3, block 3. This is the mirroring. How we are reflecting into in between the, if we are standing inside in front of mirror, means how we reflect in. Likewise, the RAID 1 will be happened here. RAID 2 means using stripping across disk. This is also a stripping, but with the humming code. But the humming code, error correction code happening here for every block, every disk. The error correction code will be happened. So the configure use stripping across disk when some disk storing error checking and correcting ECC informations. Write 2 also use detect humming code parity. The linear form of ECC write 2 has no advance, or the write 3 has no longer used. If you are having a block 0, disk 0, 1, 2, 3, 4, 5, 6. We are having a 6 level of disk, but the block A1 is having an ECC code in A parity 1. Block B2 having a B parity 1. Disk 0 and disk 6. See, let's see, disk 0 and disk 4. It contains the disk 0 is an block of A1, A2, A3, and then blocks 4 is an parity of or ECC code of disk 0. This is a